Hey, what's up? This is Dr. Taylor Krick, host of the Autoimmune Doc podcast and the owner of the Washington Wellness Center. So, if you have never followed my YouTube channel, I do study reviews occasionally. I'm going to review a study here in a second, but I also want to talk about, kind of what I do overall and what our clinic does overall. We've got um, a mental health division, which there's two counselors that work in my office, and one of them does neurofeedback. And so the point of starting with that is we see different mental health cases in our office that aren't always mine and not always mine to manage or mine to help with. But one of the things that I think of when I think of mental health things, whether it be anxiety or depression, or this study is about bipolar, I think about just inflammation. Inflammation. Now, again, that's a very general term, and a lot of times we say, my focus is autoimmunity. So in autoimmunity, there's always inflammation. There's autoimmune inflammation, and the immune system is attacking a certain part of the body. And if it's rheumatoid arthritis, it's attacking the joints. And if it's Hashimoto's, it's attacking the thyroid. And if it's MS, it's attacking the brain. But there's almost always some inflammation. But I don't think that's as well known with mental health things. And so this study that I'm going to share today is pretty interesting, and it's talking about bipolar disorder. Now, I will say before I get going on this that bipolar can be pretty crazy, as far as the diagnosis, the treatment, the hospitalizations, the mania, the depression, different things that people have been through with this. So I'm not claiming that I know everything about bipolar, but I see a lot of people that maybe have been diagnosed with X, Y, or Z condition, and maybe it's the right diagnosis and they're getting the right treatment, and they're coming to me and saying, well, what else can I do? What else can I do? And we might be looking at their inflammatory load, or we might be looking at their gut health, or we might be looking for toxins, or just what else can we do? And so this paper is really cool because it shows the inflammatory signaling mechanisms in bipolar disorders from the Journal of Biomedical Sciences. And if you followed my YouTube channel, especially where you can visually see these things, I like studies with good pictures because they can illustrate a lot of this really quickly. This is a 22-page study. I'm not going to read all 22 pages to you guys. You're welcome for sparing you. But I do want to point out some of these things because I think it's absolutely fascinating, some of the things that it says in here. Um, yeah, so and it says bipolar is multifactorial and a high individual burden and a high societal burden. A lot of these people are really, really suffering with just life, daily life. And it says, while not all patients display overt markers of inflammation, significant evidence suggests that aberrant immune signaling contributes to all stages of the disease and likely explains the elevated rates of comorbid inflammatory illnesses, meaning people with bipolar tend to have other issues. They tend to have other inflammatory issues, whether it be arthritis or it be, gut issues, or it be metabolic issues, or, fill in the blank. But that tends to be pretty common. While individual systems have been studied and targeted, there's not a lot of attention that's been given to the interconnecting role of inflammatory signals therein. So this paper goes into some of the most prominent pathophysiological mechanisms in bipolar disorder, including mitochondrial, endoplasmic reticular, calcium homeostasis, purines, kynurenine, hormone, neurotransmitter signaling, showing inflammation to act as a powerful nexus between these systems. So inflammation is involved in bipolar. Now, again, I forget if I already said this once, but a lot of people come to me and would say, like, in the medical doctor's office, they might say, this is just inflammation. And that's kind of where they stop. In my office, this is just inflammation. Where do we begin? What can we do about it? What's driving this inflammation? What might we be deficient on? What might we be toxic in? Things like that. But the goal is often trying to get inflammation down. So bipolar disorder is a highly complex, multifactorial disease with significant clinical heterogeneity, pleiotropy, and pathophysiological bias, meaning there's a lot of different things going on. Subjects with bipolar disease display high rates of inflammatory comorbidities. The aim of this study is to go through the different systems and the pathways and different things. So it gets pretty deep into the weeds, into some of the things that I like. Dysfunctional mitochondrial respiration can compound oxidative stress, meaning you're going to need more antioxidants, and increase inflammation, meaning you're going to need anti-inflammatories, and how proteins, which mediate mitochondrial and endoplasmic reticulum, communication, how they link calcium-based signaling. So again, I'm not going to get in too far to that, but I'll show you some of these things. But given the frequency of immune inflammatory comorbidities, meaning it's really, really common, we suggest that there's a detailed understanding of this dynamic and that may yield significant benefit in treating not only the mood symptoms that are associated with bipolar, but also the many other disorders that are present with this. So let's jump in. This is one of the best pictures. It says epidemiological evidence shows that BD is associated with increased rates of inflammatory things, including autoimmune conditions, hypersensitivity reactions, histamine, mast cell reactions, asthma, seasonal allergies, and cardiometabolic diseases. Though the causality is yet to be established, we can't say which caused which. There's definitely a connection, is what it says. And patients with bipolar demonstrate both central and peripheral elevations in inflammatory elements, meaning it can be measured. We can prove that these people are more inflamed, not only in their symptoms, but also with labs that can be measured. But check this picture out. This picture is fascinating. What this is showing is that while time goes along, you might be all good. And then you get this bout of inflammation. Boom, the fire, flares. And it might cause mania the first time. Then the fire settles down. It's like, I'm okay now. And then you get inflamed again. And then the next time might be depression. And then it's like, now I'm okay now. And then the next one might be back to mania or might be back to depression. That's the point of the name bipolar, is like it goes both ways. Sometimes you're manic, sometimes you're depressed, sometimes you're both, and it's one or the other. Sometimes it's hard to predict. It's hard to live with. It's hard to live with for yourself. It's hard to live with your family and your spouse and things like that. But I think that's really fascinating. And then down here's the cognition, is as this inflammatory fire continually burns, and sometimes burns stronger, and sometimes burns a little weaker, and then sometimes burns stronger again, your general level of cognition goes down and down and down and down, because neuroinflammation can lead to neurodegeneration, and that can cause symptoms of cognitive, effects like memory loss or brain fog or just decreased cognition, which would be another term for brain fog kind of thing. But you get this cognition that goes down, and this might be the healthy controls that are just more steady as things go down. So it says inflammation in the neuroprogressive hypothesis. I think this picture, even though this picture is pretty simple, fascinating, because it's like, well, how come sometimes I'm manic, sometimes I'm depressed? And I'm like, well, it's inflammation. And it's like, well, that sounds kind of crazy that you think that the same thing causes two different sides of the coin, but it does. It says it appears that it says it appears that a significant portion of patients experience neuroprogression, a progressive decline in neurocognitive function associated with increasing frequency of mood, particularly manic episodes. That as your cognition declines, you're going to have more manic episodes, more so than depressive states. Most patients experience a chronic low-grade inflammatory state, which appears to be upregulated in concert with acute mood episodes, meaning when there are acute mood episodes, it's almost always this acute inflammatory state, or they have the low-grade fire burning all the time. But it's kind of like if we pour some gas on that fire, it explodes, and then the fire is burning brighter, and then it kind of simmers back down, but it's always burning. It is suggested that prolonged microglial activation, which is brain inflammation, will compound oxidative stresses, contributing to the progressive decline in neurocognitive function. These are well-known mechanisms of Alzheimer's, dementia, Parkinson's, neurodegenerative diseases have neuroinflammatory component and an oxidative stress component to them all the time, and a mitochondrial component with the energy production in the brain. So, I don't know, it goes on to say this is the same thing. Overall evidence suggests that patients have a low-grade inflammatory state that may be enhanced during acute mood episodes. TNF alpha, there's other, particular cytokines that are involved. TNF is an inflammatory cytokine. It's also involved in other inflammatory issues like rheumatoid arthritis and things like that. But it's just an inflammatory cytokine. If I punch you in the face, you're going to get TNF alpha If I hit you on the head with a hammer, you're going to get TNF alpha. If I put you in the arm, you're going to get TNF alpha. It's just an inflammatory marker. But there's a specific connection with this with bipolar disease. There's also upregulation of something called NLRP3 inflammasome, which is a little bit harder to explain, but we're going to see it in some of these pictures in a sec. There's also some other things, mitochondrial metabolism, DNA repair, inflammation, that have been extensively implicated in bipolar disease. TNF alpha has been shown to modulate many dysfunctional processes, including the synaptic plasticity, how well your neurons are talking to each other, neurotransmission, how well your neurons are sending signals, neurogenesis, how well you're making new neurons, neuron survival, how well your neurons are surviving, apoptosis, and even cognitive behavioral functioning. Again, inflammation is associated with things like depression and brain fog, anxiety, and other things. And it's also associated with the increased risk of depression, cognitive impairment, as well as decreased treatment responsivity, especially to things like lithium, which is a very famous element or mineral or whatever it is. Mineral, I guess it's a metal. Used in bipolar. So you're going to see that in several of these pictures. And, there's lithium orotate, which is more famous in the supplement world. It's in a lot of neurostabilizing, over-the-counter supplements. But there's also other forms of lithium that are a little more, prescription-based and things like that are a little more outside of my scope. But anyway, it goes on. So it talks about this inflammation on a cellular level. Patients have increased T cell activation, which I talk about a lot, and a decrease in regulatory T cell activity. It's a teeter-totter where the Tregs go down, which are peacemakers in autoimmunity. Again, if you want more information on that, listen to my podcast about T cells and different things, but there's T cell senescence, which can be linked with early aging and neuroprogression. I don't know why they're calling that neuroprogression. Sounds like they're calling it neurodegeneration, but T cell alterations appear to be present in manic and depressed phases, but tend to normalize in remission. Yeah, it goes on. Let me read this, see if it's helpful. It's not. Significant potential exists in targeting this system. Given the pervasive influence of inflammation, significant potential exists in targeting the inflammatory immune systems in terms of antidepressant efficacy for anti-inflammatory medicines, blah, blah, blah. There are studies for minocycline, which is an antibiotic, CoQ10, some of these things that have had large antidepressant effect sizes, and it goes on, and it says these are all, I think these are interesting, significant reductions in mania have also been demonstrated with the use of supplements and nutrients like L-tryptophan. It's the precursor for serotonin and melatonin, or 5-HTP is 5-hydroxytryptophan. It's also what's in turkey that supposedly makes us tired. But you can supplement with tryptophan, magnesium, folic acid, which is B9, branched chain amino acids, omega-3 polyunsaturated fats have garnered mixed results for bipolar depression, and negative evidence for mania. So might not be good for mania as short term, but they're very, very, very good for the brain. That's very well established. But limited evidence suggests no significant benefit for most medications as maintenance therapy. Other inflammation-reducing interventions like probiotics, curcumin, colchicine, and ketogenic diets have been proposed with some promising initial findings, but it's like they need to be looked into a little bit more. But and importantly, numerous studies from anti-inflammatory agents to be the most beneficial when your inflammation is high. If the fire is big, then the extinguisher is more effective. If the fire is small, then the fire extinguisher doesn't do as much. Duh. So yeah, pretty interesting. Then it goes, that's inflammation. This is different, and it's really important, but it's energy metabolism and oxidative stress. These are your mitochondria that produce all of your brain's energy, including neurotransmitter production and neurotransmission and neurocommunication of these neurons talking to each other that kind of make up, our mood of how we are in relationship to the outside world. Are we depressed? Are we happy? Are we sad? Are we motivated? Are we lethargic? These different things. But the mitochondria in each of your, let's say, 100 billion neurons. 100 billion neurons, you've got like 10,000 mitochondria, and they power all of this. I've heard it said that there's a quadrillion mitochondria in the brain. So really every brain issue is a mitochondrial issue, but mitochondria can be uh, linked to inflammatory cell activation through some of these pathways. Mitochondria produce approximately 90% of all the reactive oxygen species, making them major regulators of cellular stress, synaptic plasticity, calcium homeostasis, alterations in mitochondria and the structure or function, which is commonly seen in bipolar disease, can result in less efficient energy production, as well as impaired antioxidant capacity. So there's inflammation, there's oxidative stress, there's mitochondrial issues, and right away, just from those facts, there's a lot we can do in the natural side of things to support mitochondrial function, to support inflammatory load, to look into the gut microbiome as far as a root cause of inflammation and things like that. But it keeps going. And I don't know, again, this is 22 pages long. We're only on page 4, so let me get to some of these pictures. But they're all just pretty interesting, I would say. And let me just talk about a couple others. But there's well, I don't know, increased oxidative damage to lipids. There's lipid peroxidation. There's increased levels of nitric oxide levels like INOS, which is cytokine-inducible nitric oxide. And markers of oxidative stress correlate with early age of onset, longer duration of illness, and increased frequency, meaning the more oxidative stress you have, the worse your BD is going to be. And the sooner it's going to come on and the longer it's going to stay and the harder it's going to be to get it to leave, which is, again, not that shocking, but makes sense. But antioxidants can be helpful. Lithium treatment has been associated with decreased markers of oxidative stress and increased mitochondrial complex 1 activity. So lithium is a big deal in the bipolar world, even from a neurologist standpoint or a psychiatrist standpoint or whoever might be, treating this from a medical standpoint. They're usually doing lithium, but lithium provides a long-term neuroprotective benefit by reducing overall oxidative damage to neurons by ameliorating mitochondrial dysfunction. In summary, it appears that mitochondria are altered even before the symptoms arise. Their impaired function leads to increased oxidative damage and then more inflammation. And then that leads to more mitochondrial issues. So it keeps going and going and going. And that's basically what these are saying. Calcium, I'm not going to talk about calcium. It's a calcium homeostasis is pretty intense. But if somebody's got abnormal calcium on a lab, it's like, okay, something's going on because calcium is pretty tightly regulated, especially in the blood. But there's a lot going on with that. So figure 2, we're about to see the figure on the next page, but it shows the oxidative damage. So let's show this. Here's a whole another paragraph about inflammasomes. But again, check out these pictures. Beautiful pictures, seriously. But here's some things. Here's the healthy controls. They've got the cellular stress, inflammatory, oxidative, hormonal. Lithium can block these things, inositol, but this is healthy controls. Whereas down here is more bipolar, and the UPR is overwhelmed, which is a protein recycling pathway in the endoplasmic reticulum. I don't even know. It's too intense to explain, but we get more of this NF-kappa B that's an inflammatory cycle. It can keep going and going and going. We get these mitochondria that burst open and spill out their contents, and that can lead to microglial activation, which is inflammation, NLRP activation, which is inflammation, apoptosis, which is death of cells. Do we get these damage signals? And when the body senses damage, then the immune system responds to come and mop up all the damage. We also get these NMDA receptor activations, and lithium and other things like ketamine can block these calcium channels or these NMDA channels, which stands for N-methyl D-aspartate. But it's pretty interesting. But I think the point is that lithium can reverse some of these things, and lithium can be really good. But we get less brain-derived neurotrophic factor, which exercise increases. Things like a lion's mane mushroom have been shown to increase that. But all these things to a nerd like me are like, oh, this is all bad stuff that happens in bipolar, and this is all normal stuff up here that isn't working properly when somebody has bipolar disorder. So goes on saying a bunch of different things, talks about ketogenic diet, talks about bicalin, which is Chinese skull cap being used, and I'm just kind of seeing that, I'm just kind of picking it out, but bicalin, really good for neuroinflammation. I use it all the time for neuroinflammation as regards to a nutraceutical supplement, but there's other things that we'll see in here like ketogenic diets, um, other, nutraceutical things that I'm kind of looking for so that I don't get, lost in the weeds reading this and bore you. But those are some things that this study goes through. The proposed mechanisms of a ketogenic diet are diverse, including the regulation of neurotransmitter signaling, the regulation of mitochondrial function, improved insulin sensitivity, and inflammation. Ketones, beta hydroxybutyrate, a ketone, can attenuate stress-induced behavioral and inflammatory responses by inhibiting this NLRP3 inflammatory pathway. So again, there's a lot of different interventions that may hold promise as adjunctive therapy, especially in patients with a high metabolic burden. But there's dietary strategies, there's microbiome strategies to decrease the inflammation, to decrease the TNF alpha, to increase things like IL-10, to decrease IL-1 beta and IL-6, the inflammatory cytokines. So there's lots of things that we can do for that. But again, I'm trying to stay relatively quick here. Purines are another thing that are more linked in my mind to like gout and some inflammatory issues like that. Purine dysfunction has been linked to a wide array of mood and anxiety symptoms, including disturbed sleep, anhedonia, which is the loss of pleasure, cognitive impairment, agitation, severity of emotional symptoms, changes in appetite and energy levels. Uric acid is what can be measured in labs. Again, I measured it in somebody today. There's was like 7 point something. And it says on the lab, it says the therapeutic target for gout patients is less than 6. So I was like, hey, you don't have gout, but even if you did, we want to keep it less than 6. So 7 is higher than we want it to be, but that can be measured. Uric acid can be measured. And it potently increases inflammatory cell activity, specifically via that inflammasome. And that mechanism has been observed in BD as well as cardiovascular disease. The guy that I was seeing has cardiovascular disease, and we were going through his labs and his inflammatory markers and his uric acid and his, diabetes and blood sugar markers and things like that. And they were just all jacked up. His vitamin D was 20. His omega index was like in the ones. So there's a lot we can do for his inflammation level, but he doesn't have BD. He had heart disease. So blah, 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 keeps going, talks about, again, the uric acid. So I don't know. I don't think a lot of this matters, but, and I don't, is there another picture? There's a couple other things I want to talk about. Oh, there's another picture about the kynurenine pathway. Johnson and Johnson. I think, I don't know if that means like the company Johnson and Johnson or like two guys and girls named Johnson. But it could be either. But they're talking about this inhibition with high levels of inflammation. Again, I don't know. That's kind of a stupid joke that caught my eye. The kynurenine pathway is a fascinating thing that I'm not going to get into in this paper or video. I've got other videos on YouTube talking about this kynurenine pathway. In fact, I have one video that's called like why you should consider a ketogenic diet for MS. And I go through all this literature about the kynurenine pathway and kynurenine activation and its association with MS, and then how a ketogenic diet can impact this kynurenine pathway. I also measure kynurenine metabolites and things all the time. So there are some things in here about this kynurenine and tryptophan and things like that again, I'm not going to get too far into, but it can lead to mood and sleep abnormalities because of tryptophan depletion and things like that, and effects on serotonin and melatonin. It can lead to fatigue because of NAD depletion, um, or it can lead to anxiety and neuroexcitation through NMDA activation and things like that. That's a more associated maybe with the BD and bipolar disorder. But I don't know, pretty interesting in my mind. But it also, pro-inflammatory conditions can exacerbate kynurenine toxicity by increasing blood-brain barrier permeability, leading to an influx of inflammatory things into the brain. The brain has a barrier that keeps it pretty well protected from a lot of things like toxins and immune cells and bad bugs and things like that. But when that blood-brain barrier gets destroyed, like in a head trauma or like in leaky gut or in some of these mechanisms, the blood-brain barrier gets destroyed and then things can enter. Mast cell activation could cause blood-brain barrier dysfunction, all these things, LPS, whatever, fill in the blank. But a lot of it can come from the gut. Um, and yeah, so here's the next picture. It's kynurenine. And so it's talking about, let me try to explain this. Don't know what these blocks are, but lithium can block the chronic stress response. Chronic stress can block tryptophan's metabolism into serotonin, and then hence its metabolism into melatonin. But I don't know where these other blocks are coming from, but melatonin maybe blocks inflammation, inflammation blocks melatonin, but this part doesn't necessarily make sense to me. But you get this upregulation of IDO. IDO is an enzyme that converts tryptophan into kynurenine. So that's one of the mechanisms that speeds up this kynurenine pathway. They can lead to things like quinolinic acid, which is very inflammatory and neuroinflammatory down here. And we get these inflammation things. We get over here, melatonin helps with a lot of this. It increases neuroplasticity. It decreases glutamate toxicity. It decreases mitochondrial stress. It decreases inflammation. It decreases NLRP3 activity. It decreases insulin resistance, and it decreases lipogenesis. And again, I've got some videos on YouTube talking about melatonin a little bit more too, because melatonin is a pretty interesting thing in the mitochondria. It's not only released due to darkness and the sleeping hormone or the darkness hormone, things like that. What we're now finding about melatonin is that it's kind of a guardian angel of the mitochondria, and it's one of our body's master antioxidants, even more so than things like glutathione. But over here, there's a lot of bad stuff. Over here, we got a lot of bad stuff. We get basically the opposite of all these. We get this microglial activation. We get these damaged mitochondria. We get these DAMPs that drive this inflammatory state, this NLRP, inflammasome activation. And we get this increase of quinolinic acid, which is associated with an increased risk of Alzheimer's, dementia, neurodegenerative conditions. But we get all these things that are the opposite. We get decreased neuroplasticity. We get increased glutamate toxicity. We get increased mitochondrial stress, increased inflammation, increased NLRP, increased insulin resistance. Obviously this paper is about inflammation and bipolar disease, but these pictures look very, very similar if you study head traumas. These pictures look very, very similar if you study Parkinson's. These pictures look very, very similar if you study dementia, because it's like what damages the brain? These pathways and these mechanisms. And a lot of these things would be true if I hit you on the head with a hammer, or you played professional football and you donked your head a million times, or things like that. A lot of these things, the mechanisms are the same. So I'm going through them really, 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 really quickly. And it might be over your head, but the point is inflammation is a driver of bipolar disease. Now we're on page 11. So let me keep going. LPS-induced depression. That's interesting in and of itself. LPS comes from the gut, can also come from other areas, but it just drives inflammation, toll-like receptor activity, things like that. But we can measure, I saw another person today that we've measured reactivity to LPS, both IgA and IgG, but it was coming from her gut, and her bloating is a lot better. She just went to her primary care. She said all her blood labs are better. Her dentist or her endodontist is like shocked at how quickly her mouth is healing. But when we first did her gut lab, she had this LPS reactivity. And I don't know, I could keep going and going and going on BDNF, on glutamate, on GABA, the opposite of that, all these different things. I could keep going. Here's some other things, hormones and circadian rhythm, things like cortisol that spikes in the morning and say, hey, get up, get out of bed. It's morning. The sun is out. We got stuff to do. And then melatonin that's kind of on the opposite rhythm. That's like, as cortisol is coming down, melatonin is starting to rise, with regards to the circadian release of melatonin. Serotonin, dopamine, they all have established roles in mood regulation, and they can be messed up with BD, particularly manic switching, or if somebody's suicidal, or if they're having bad treatment response, you have these different neurotransmitter dysfunctions. There might be like a ton of adrenaline or a lack of dopamine or serotonin imbalances or things of that nature. Um, but yeah, I don't know. This is a pretty deep one. Melatonin goes into all this stuff that I already kind of pointed out in the picture. And inflammation will depress melatonin release, so it kind of goes both ways. Um, Glucocorticoids, meaning like cortisol, but also meaning like prednisone or things like that. They're anti-inflammatory and they're pro-inflammatory depending on the state and things like that. Cortisol, whatever. But I'm skimming through the rest of this because I think it's just continuing to repeat what I've already shown. Glutamate signaling is also really important. Glutamate is excitatory. It's excitatory. So the MSG, the G in MSG, meaning like MSG in Chinese food or MSG as a food additive or MSG as a kind of neurotoxin. The G stands for glutamate, but glutamate's excitatory. And the opposite of that is GABA. GABA is calming, glycine is also calming. But yeah, so I don't know. I think that I've beat a dead horse with this study, but it's fascinating. Again, I pulled this study up, showing it to somebody who came to me with bipolar. So that's exactly what I do in my practice is like, hey, you come to me with X, Y, or Z issue that you've been diagnosed with and you've been treated for and all these different things. And you're coming to me saying like, what can I do? What can I do? What can I do? What can I do? And there's a lot. The answer is there's a lot. It's almost in clinical practice, it's almost like there's too many things. We need to start in priority order and see, well, what are you deficient on? And if your omegas are low, if your vitamin D is low, if your, vitamins and nutrients are low, we want to raise them. If your inflammatory levels are high, we want to try to get those down. But then looking into the gut microbiome, looking into toxicity, considering histamine and other mechanisms that could be involved. But all these things are involved. And again, 22 pages. I think it's just hard for this paper to not be pretty intense because here we are on page 16. And I think we get the point and there's no more pictures. So again, as a conclusion, the first line treatments, which are helpful for many patients, they're not ideal. So there's other things that we need to look at, like, well, what else can we do? And inflammatory signaling draws a common thread between so many of these disease processes, seemingly unrelated disease processes, notably absent from this review because they just didn't have time to dive into it, are the effects of the microbiome. I've got many other studies on my YouTube channel and otherwise showing the connection with the microbiome and inflammation. It's a pretty well-established connection these days, but it appears to mediate a significant portion of the inflammatory signals discussed here. Though in its relative infancy, we anticipate that recent improvements in complexity analysis will further solidify these mechanisms that we're kind of shining a light on in this paper. While excess inflammation is not ubiquitous in bipolar disease, it does present an opportunity to objectively segregate a large subset of patients who may respond better to targeted therapies. Meaning if somebody comes in with bipolar disease and you measure their inflammation and they don't have much, they might not be the ones that will respond to this. But if somebody comes in and they've got, look, there's other factors. You grew up in a war-torn country, you saw something traumatic as a child. There's all kinds of different factors that play into our psyche and our state and these traumas, thoughts, traumas, toxins, that we've been exposed to throughout the years. So there's all kinds of variables. But if somebody has inflammation is a worthy target to aim at. And that's kind of the point of this entire paper. So hope that was helpful without being too confusing or rambly or anything like that. But hopefully that helps. And if you want help targeting your inflammation, come to somebody like me. And that's kind of our goal is, well, what is inflammation? What can we measure? What can we target? What could be driving it? And what are the mechanisms involved with it? That's kind of the basis of my practice and my whole YouTube channel, my whole podcast, and all the different factors and conditions that might come from that. That's kind of what I do.